Welcome, everyone. Today, we're embarking on a fascinating journey into the world of electronics. Electronics play a pivotal role in our everyday lives, from the gadgets we use to the technologies that power our homes and industries. But before we dive into the intricacies, let's clarify what electronics mean and how it differs from electrical systems. What is electronics and its importance in our everyday lives? We'll take a quick journey through the history of electronics, tracing its evolution from the early days of simple circuits to the advanced technologies we see today. Electronics and electrical engineering, while often used interchangeably, actually focus on distinct aspects of electricity and have unique applications and components. First, let's talk about the scope and focus of each field. Electronics is all about the study and application of devices that control the flow of electrons. This typically involves working with semiconductors, vacuum tubes, or gas. Think of it as the field that deals with tiny, intricate components that control electronic signals. On the other hand, electrical engineering focuses on systems that use electricity to perform work. This field is more about harnessing and distributing electrical power on a larger scale. Next, let's look at the components used in each field. In electronics, you'll encounter components like transistors, diodes, resistors, capacitors, inductors, and integrated circuits. These are the building blocks of small, complex electronic devices. For electrical engineering, the components are bigger and more robust. You'll see transformers, electric motors, generators, power switches, circuit breakers, and relays. These are essential for managing and distributing electrical power. Now, let's discuss where these components are used. Electronics are found in devices we use every day, such as computers, smartphones, televisions, radios, and communication devices. They are also crucial in control systems, signal processing, and microprocessors. Imagine all the gadgets and technology that make our lives easier and more entertaining. That's electronics at work. Electrical engineering has applications in power generation plants, electrical grids, home wiring, industrial machinery, electric vehicles, and HVAC systems. This field is all about generating, transmitting, and distributing the power we need to run our homes, factories, and cities. In terms of scale, electronics is all about processing information, digital signal processing, data transmission, and computation. It's the brains behind our smart devices and modern communication systems. Electrical engineering is concerned with delivering and controlling power. This includes power distribution networks, electric power plants, and large machinery. It's the muscle that keeps our world running. What is electronics? Electronics is a branch of science and technology that focuses on designing, developing, and applying devices and systems that use electricity to perform various functions. In simpler terms, it's all about using electrical energy to make things work in specific ways. In electronics, we study and use different components such as resistors, capacitors, diodes, transistors, and integrated circuits. These components are like the building blocks of electronic devices. They manipulate the flow of electrical current, or electrons, to perform specific functions. For example, resistors control the flow of electricity, capacitors store electrical energy, and transistors can amplify or switch electronic signals. Now, why is electronics so important? Well, think about your daily routine. From the moment you wake up to the time you go to bed, you interact with numerous electronic devices. Understanding electronics helps us appreciate the technology that powers our world and prepares us for future advancements in various fields like communication, healthcare, entertainment, and automation. Let's look at some specific examples of how electronics is part of our everyday lives. First, consider your television. Your TV uses electronic circuits to receive and display broadcast signals. Whether you're watching your favorite show or streaming a movie, electronics make it possible. Next, think about your microwave oven. This appliance heats your food using electronic control systems. You set the timer and power level, and the microwave uses these settings to cook your meal. And let's not forget your refrigerator. Your fridge maintains the right temperature to keep your food fresh using electronic thermostats and sensors. It automatically adjusts to ensure everything stays at the perfect temperature. Moving on to communication devices, let's start with smartphones. These are mini-computers that combine multiple electronic components to enable calling, texting, internet browsing, and running applications. They are powerful tools that keep us connected and entertained. Another key device is the computer. Whether it's a desktop, laptop, or tablet, computers process data and perform complex calculations using microprocessors and memory chips. They are essential for work, education, and entertainment. Now, let's look at entertainment systems, beginning with gaming consoles. These devices use graphics processors and electronic control systems to provide interactive gaming experiences. From simple games to complex virtual worlds, electronics make gaming fun and immersive. Finally, consider your sound systems. When you listen to music or watch a movie with surround sound, electronics amplify and modify audio signals to produce high-quality sound. They enhance our listening experience, making it richer and more enjoyable. And that's a brief overview of what electronics is, its importance, and how it integrates into our daily lives. Now, let's take a journey back in time to see how it all started. Buckle up as we explore the milestones that have shaped the world of technology as we know it today. Let's start in 1837, when Samuel Morse developed the telegraph. Imagine a world where you could only send messages as far as a horse could travel. Morse's invention changed everything. By sending electrical signals over a wire, the telegraph allowed long-distance communication using a series of dots and dashes, known as Morse code. This was revolutionary because, for the first time, messages could travel faster than any human or animal could. Fast forward to 1876. Alexander Graham Bell invented the telephone. Now, instead of just sending coded messages, people could talk to each other over long distances. This was a huge leap forward, as it meant voices could travel over electrical wires, bringing people closer together in ways never before possible. 1904, the first vacuum tube. In 1904, John Ambrose Fleming invented the vacuum tube. This device could amplify electrical signals, making it possible to create early radios and televisions. Imagine sitting in your living room for the first time and hearing a voice coming from a box or watching moving pictures on a screen. The vacuum tube was essential for these early forms of electronic entertainment and communication. Next, in 1947, John Bardeen, Walter Brattain, and William Shockley invented the transistor. This tiny device could amplify and switch electronic signals, and it's considered the foundation of modern electronics. Transistors made it possible to create smaller, more efficient electronic devices, paving the way for everything from computers to hearing aids. 1958, the first integrated circuit. In 1958, Jack Kilby created the first integrated circuit. Imagine taking several electronic components and putting them all onto a single silicon chip. This innovation led to the miniaturization of electronic devices, meaning gadgets could be made smaller and more powerful. Jumping to 1969, Intel developed the Intel 4004, the first microprocessor. This was a complete central processing unit on a single chip. It enabled the development of personal computers and complex electronic systems, making computing more accessible and powerful. 1970s, the rise of personal computers. In the 1970s, companies like Apple and IBM started developing personal computers. These weren't just for big businesses or government labs anymore, they were for everyone. Personal computers brought computing power to individuals and small businesses, changing how we work and play. 1980s, the digital revolution. The 1980s saw the digital revolution, a time of rapid advancement in digital electronics. This decade introduced consumer electronics like video game consoles, personal computers, and digital watches. It was a time when technology became a part of everyday life. 1990s, the Internet and mobile phones. The 1990s brought the rise of the Internet and mobile phones. Communication was transformed as it became easier and faster to connect with others and access information. The Internet opened up a world of possibilities, and mobile phones meant we could stay connected on the go. 2000s, the era of smartphones and portable devices. In the 2000s, smartphones integrated communication, computing, and entertainment into a single portable device. These powerful gadgets changed how we interact with technology, making it a constant companion in our daily lives. 2010s, advances in AI and IoT. Finally, in the 2010s, we saw significant advances in artificial intelligence and the Internet of Things. AI made technology smarter, and IoT connected everyday devices to the Internet, creating smarter homes and more efficient technology. And that's our journey through the brief history of electronics. From the telegraph to AI, each milestone has brought us closer to the interconnected, high-tech world we live in today. It's time for a self-check to review what we've learned. Read each question carefully and choose the best answer from the options provided. Let's get started. 1. What is the primary focus of electronics? A. Study and application of systems using electricity to perform work. B. Study and application of devices controlling electron flow in semiconductors, vacuum, or gas. C. Study and application of electrical energy generation. D. Study and application of mechanical systems. The correct answer is B. Study and application of devices controlling electron flow in semiconductors, vacuum, or gas. 2. Which invention is considered the foundation of modern electronics? A. Telegraph. B. Telephone. C. Vacuum tube. D. Transistor. The correct answer is D. Transistor. 3. Which field typically deals with smaller scale, low power applications? A. Electrical. B. Electronics. C. Civil. D. Mechanical. The correct answer is B. Electronics. 4. What significant event in electronics history occurred in 1969? A. Development of the first integrated circuit. B. Invention of the transistor. C. Development of the first microprocessor. D. Introduction of personal computers. The correct answer is C. Development of the first microprocessor. 5. Which decade saw the rise of the Internet and mobile phones? A. 1970s. B. 1980s. C. 1990s. D. 2000s. The correct answer is C. 1990s. Remember that electronics are not just about circuits and components, they are about innovation, creativity, and improving our way of life. Whether you're aspiring to be an engineer, a hobbyist, or simply curious, the knowledge and skills you gain in electronics can open doors to endless possibilities. Thank you for your attention and curiosity. I hope this presentation has sparked your interest in electronics and inspired you to explore further. Let's continue to learn and innovate, shaping a future powered by the wonders of electronics.